Good to see you. Everybody from the internet void and everybody here on site on Grand Parade, William Hill. It's a 69.
Yep, 69.
Since 69th meeting. So it's been a while. I hope it's not the last one. We welcome you. My name is МаciеจЛелуззь.
And ПаWеł.
We welcome you here with our colleagues as well, Maria and Alina, that helping us out today to organize this meeting. Thank you very much for William Hill for supporting us with the venue, some food and beverages. Sorry. I hope you enjoy the same beverages and food at home or better, so don't worry. What we will start? We will start with a session from William Hill, from our partner on this meeting. Can we ask to join us, the speaker? Slowly. Perfect. Okay, good. So Mateusz, if you will stay till this line, the people will see you as well there. What you will talk about a little bit, just a brief, if you need to advertise this to the people there to stay, because here they will stay because we close the door. So it's no problem, right, for on-site. All right.
Yeah, so hello everyone. My name is Mateusz. I'm the SRE architect here at Grand Parade. And I will be talking about the kind of naughty things that you're not supposed to do, like queuing users instead of scaling your systems.
It's a perfect subject for 69th meeting. All right, the stage is yours. We will let you hear. But remember, guys, we'll have pool at every end of the presentation. Going to be a QR code, so don't hesitate to take part in it, because here we have, could you move a little bit? Yeah, thank you, sir, because you know that here are stuff that we will both choose for the people in the on online and on site. Okay, so there are gonna be some and vouchers. Yeah, vouchers for AWS. Like every time I'm saying, not Amazon. Okay, so you will not be able to buy T-shirts and pillows with Nicolas Cage, but you will be able to spin up some services. Okay, all right. So we can start. You ready? You ready?
Yeah.
Perfect. The stage is yours.
Good luck.
Okay, so as I've mentioned, I'll be talking about queuing instead of scaling. So let me start about the brief explanation of what we do in the company. So Grand Parade is the technological backbone of William Hill, which is the biggest gambling industry provider in the UK. And with our global reach, we aim to provide a safe and enjoyable experience for our users. And as SRE, not only do we focus on providing improvements in stability and resilience and performance of our systems, but we are also actively looking for pain points both on our internal systems and in the ways our customers interact with us. And with our wide skill set, we might one day find ourselves automating a manual process for a team that simply lacks the skill set to do so themselves, while the very next day we might be brainstorming ideas with mobile app teams. One such pain point is the Grand National. So AWS famously has started with the extra capacity Amazon had during Black Friday, and Grand National is our Black Friday. It's the most iconic horse race in the world, with over £1 million in the pot. It's the highest value jump race in Europe. It draws in not only people who don't usually bet on horses, but it also draws in people who don't bet at all. Many people will just place a £1 bet on their favorite horse to give that extra spice to the pint of beer they drink at the bar. On the day itself, we are used to seeing about 50% more customers that we do during any other day. That means more than Euro, more than Premier League, more than anything. And what we have here is the chart showing the number of bets placed both in 2023 and 2024 during Grand National, peaking at over 10,000 bets per second, while a usual very busy day for us is around 6,000 to 7,000 bets. Preparations for Grand National at our company actually begin right after the race, when we start reviewing and compiling metrics which we will use to drive our decisions and planning for the next year. The work in earnest starts about 4 months before the race, where we pool domain experts from almost every team within the company to plan and identify potential breakpoints during the race. That is also the time that we communicate with our commercial teams and adjust our predictions based on any incentives that they might be planning. For example, this year we have issued over 300,000 vouchers for free bets to our customers. Also, our performance testers get very busy around that time, and that culminates in a performance test in production, which aims at replicating every single KPI we've set at the same time. So why queue and not scale? Well, any technology and any tech architecture that we might decide upon has its own limits, and sooner or later those limits will be reached. For example, a database technology chosen years ago might be both expensive and time-consuming to migrate off of. And in the landscape that we all here work in, it's not always makes sense to make those decisions at a given time. If we have a migration project for an entire system set out for 3 years, it doesn't make much sense to try and migrate off a single component earlier than that. And additionally, even if all of our systems can scale beautifully, that's not to say the same for our partners and associates that provide third-party business and technical functionalities for our customers. It's not always possible to just swap them out for someone else who can provide us with the capacity that we need for a single day. Lastly, what you can see here, the green chart represents the number of deposits, while the yellow one represents the number of withdrawals. What you can see is very high traffic that then drops to 0, then shoots back up. And the yellow one is with the queue, meaning that most of that peak would culminate in a single minute as everyone rushes to decide to check the results. Reactive scaling will simply not be able to handle that. Most matter of factly, it will work against you as the systems try to scale down seeing little traffic. So you have to adjust your scaling for that single day anyway to change the minimal sizes of your scaling groups. Additionally, any predictive scaling based on predictions, be it classical algorithms or AI, will have a single day a year that they can use as an input data. And those two systems for deposits and withdrawals are largely separate. So naturally, when you are faced with a problem like that, the first thing you're supposed to do is see what your competitors are doing. And as we found out, they aren't doing much. Some of them would just splash their site with a static page and then tell customers to come back later. That way, they organically smooth out the post-race peak. Others will use off-the-shelf solutions available on the market for queuing. And those solutions both have their own limitations and they are quite expensive. We know because we use the same ones. For example, last year, the Grand National main race was delayed by 15 minutes. And while our competitors who used off-the-shelf solutions that were under a contract and a schedule had no choice but to splash their sites, while we kept accepting bets until the very moment the race started. And lastly, native. Nowadays, most of our traffic comes from mobile devices and mobile apps. During the national, that can exceed 80% of total traffic that we see on the site. So anything we build must be focused on providing a smooth and nice experience for those customers. So what we've started was a solution provided by the AWS Solutions Library, and is a great resource that provides solutions built either by certified third parties or engineers working at AWS itself. It's a full package with usage examples, documentation, application code, infrastructure code. And in this case, what essentially is happening is that a user arriving at the site will be redirected using a Lambda dash, and then they will be placed in a waiting page for the queue. From there, a request will be made to the API public gateway that will get then shot straight to Amazon SQS. At that same time, a response will be returned to the user with the unique request ID. That way, the main bottleneck of the system, which receives the highest amount of traffic, is decoupled. And the Lambda function that sits behind that SQS queue then can asynchronously start assigning positions in the queue. That's done using Redis as a locking mechanism. And then the request ID is assigned a unique position in the queue, which is saved in DynamoDB. Once that happens, a user has their own unique position, which does not change in time, meaning it can be cached. And the only changing value is shared across all users, and that's the threshold. As the threshold increases, it will eventually reach the position that the user was assigning, at which point that user is allowed into the site. That is done through another request, which then generates for them a JWT token, and then letting the user into the site is as simple as verifying the signature and the expiry time of the token. So with that design, we had to make a few changes. The main one was obvious. With 80% of native traffic, we had to make sure and work closely with our native teams to build an API that fits in our existing technological landscape and allows smooth experience across any device type. Next, we also wanted to recognize our loyal customers and prioritize their access to the site. The solution that AWS provides was built around the assumption of a single interaction within the user journey, like, for example, buying a ticket, while we wanted to cover the entire user journey and cover the entire site. And lastly, the engineers that built that solution simply didn't test it on the numbers that we see. They tested it on pretty high traffic, but have not reached the limits of the solution. So we actually worked closely with multiple teams within AWS, including the team that built that solution, to identify the bottlenecks and devise strategies to overcome. And here's what we've arrived at. The main difference is here, where instead of a single entry point being the portal that you want to cover with the queue, there are now two entry points, one being the web version, which behaves very similarly, meaning there's a Lambda function at edge which redirects the users into the queue. The other one being nil. Nil is short for native integration layer, and it's our single entry point for all interactions that the native applications do. The next major change is in the SQS. There are now two queues, one serving standard users and the other one serving priority users. It's done in such a way to keep all the benefits of the original architecture in terms of the Lambda function and the Redis locking. With this, the Lambda function knows straight away how many messages there are in the batch and which batch the messages belong to based on the name of the queue. So it can lock the required number of queue positions in Redis straight away and unlock it for other concurrent executions. Lastly, the change comes here in the private API. In the original solution, the public API served all the interactions with the customers, while the private API served all the management actions. In our case, we've decided to create an extension over the public API, meaning that the private API implements both all the customer-facing functionalities and the management functionalities. That is done so that nil applications sitting on EKS do not have to exit into the public internet and route themselves back into the public API faced by CloudFront. Instead, we save on the network latency and just handle those interactions directly within the VPC. Here's a preview of how our internally built panel for managing and controlling the queue looks like. The most interesting parts are the numbers. So we have 2 columns for the standard and for priority queue. And 444,000 people is the number of people who have actually entered the queue. Now, 470,000 is the number of the threshold that allows users to enter the site, meaning that there is at current time 26,000 people who would get redirected to the site immediately after entering the queue. The waiting number represents the number of people who could potentially enter the site, but can't at the moment, either because the threshold hasn't reached them yet, or because they have not exchanged their position in the queue for the entry token. That can happen if they, for example, decide to abandon their session without waiting for the queue to reach them. *30 in this case represents the number of active users currently on site who have access. Here you can also see the preview of how it looks on native. One of the improvements that we've done this year is the introduction of this result list. We show both provisional results based on reports we received from the track, as well as the official publishings by the judges once they arrive. The reason for that is that we've learned that a large number of customers are only interested in the results. They don't need to log in, they don't need to check anything. So if we show them here, they don't have to wait in the queue, and we don't have to, for example, show them leaderboards for football or anything else on the side they're not really interested in. This year, we've seen a peak of 14.2 thousand bets per minute, which was the second highest we've seen in all of our history. Also, the number of users on the day was 40% higher than what we've seen last year. And yeah, that's pretty much it. So now I'm open for your questions.
Any questions? Hey, don't hesitate. Come on. Yeah, you have. Perfect.
Hi, hello. So if I understand you correctly, so we basically are queuing users. So let's say it's like similar to the stock market. So basically when I press a button, I make a bet. So I get the price on the execution price at that time, or when my record is basically like the bet is placed.
So this is slightly different. Like when you place a bet, yes, you get the rates at that moment. However, we don't use the queue for betting. All of that we can handle fine. It's only after the race ends and everyone wants to check if they won or not. That's where we see the highest amount of traffic, because people bet throughout the day up until the race. And then after the race ends, all the people throughout all that day want to check the results at the same time. So that's the only time that we actually need that queue. So in that case, what happens is your preliminary results of your bet would be shown you on the page as soon as you log in. However, the settling of the bets is a process that does take time. So you might not be able to withdraw your money right away. You might need to wait. But that too, we've seen large improvements with the introduction of the queue. This year, we've settled all the bets, meaning that everyone who bet with us could withdraw their money 40 minutes earlier than our predictions.
Okay, great. Thank you.
Yeah. Are you experiencing any issues while the race is live? I mean, do you support such features like cash out, and maybe it makes some troubles on your side, or you just don't allow cash out, and when the race is live, you just don't let people to change anything?
Yeah, so the the most optimal customer experience here is quite difficult to achieve. And we could potentially allow people to cash out or do other actions or their accounts. However, we'd have to disable those parts and those functionalities that would be at risk of being overloaded by the amount of traffic. And we've learned that it's better to just not allow anything. So during the queuing, if you are in the queue, you can't even log in.
Any questions?
I've got one, because you said that you are using API gateways, and pretty much a lot, I think. And if I remember correctly, there is like a hard limit for API gateway of 10,000 requests per peak. I think that, I don't remember if that was in minute or in 10 seconds. Do you handle this problem somehow, or do you even reach this limit, and how you manage?
So what is great about this architecture, maybe even here, is that the way it's built around the customer position that essentially does not change, and a common shared counter that increments, is that both are cacheable. So that way we can largely decrease the amount of traffic on the API gateway, but simply caching those responses.
Okay, thanks. Any new questions from the publicity?
Right. Do we have any questions from the internet as
I think
well?
we've got.
Okay.
So my question is, do you use this solution also for things like DDoS or any random spike in the traffic, or only for predefined events?
So for DDoS, the built-in solution that AWS has around the firewall and so on are perfectly fine. We have no issues with that. And outside of Grand National, there is no peak that we cannot handle.
Can you tell again what is the difference between the say, normal day, normal traffic and the peak time on the Grand National? Was it threefold or more?
So it's hard to tell what the peak would be if there was no queue. Throughout the day until the race start, we see about 40 to 50% more traffic, depending on which metric you look at, the number of users, number of bets, and so on. When it comes to post-race, meaning mainly withdrawals, that's several orders of magnitude.
Thanks. All right. If there is no question, thank you very much, Mateusz.
Thank you.
Thank you. Yeah. Cheers of applause. Thanks. Who's next? Oh my God. Who's next? Who's next? All right. Very good. Very long time no see. Yeah, I know. Don't worry. Just push another button. Yeah. Good. All right. So before Krzysztof will start, we ask you to scan this QR code. Your IT security guys will be very proud of you when you will do it.
There is
so no
issue
worries. We'll sell your data later, right? No, but honestly, it's going there. So if you don't trust this, you can type that and you go directly to the pool. There are some questions. So remember, at the end of our presentations, we'll pick up some winners for this and some vouchers, okay? Krzysztof, what you will talk about? Could you tell to our lovely people in the void?
Hello. I will be talking about IAM roles and SSO, single sign solutions for AWS, how to start with them instead of using IAM users.
Nice. Krzysztof coming to here from Brainly. He worked for Brainly. I don't know if any of you remember, but we had some meetings years ago before pandemic in Brainly office. So I'm very happy that you come back to the stage of AWS User Group Cracow. Should we start, Maria? What you think? That's perfect. You ready? Could you start your presentation? Maybe, no, we didn't do like this. It's going to be too easy. You will talk as well about this technology that it's boat, yeah, right? About some big giant boat, some technology. Don't remember.
Yes.
All right, perfect, very good.
Yes.
Yeah.
It's here.
Good, good.
Oh.
Krzysztof, the stage is yours. Thank you. Hey guys, a little applause. Just a little bit, like cheer him up. Yeah, go for it. Woo! Krzysztof, come on. He's real stressed a little bit because it's a huge multimedia presentation, so everything can go wrong. So if it's gonna go wrong, don't hesitate to ask him the bad questions, don't worry. It's good? Good. Thanks.
Okay, I think we are ready. So my name is Krzysztof. Pretty hard to pronounce for non-Polish speaking people, so you can call me Krzysztof. You can briefly read about me here. So I have some experience in cloud and in general IT. And I work for Brainly. And currently, Brainly is #1 educational AI application in the world. We provide several offerings using artificial intelligence that help students around the world to help with their homework, to help them learn, actually, and to understand even their own books, their own books that they use on a daily basis. We provide offerings for teachers, and we serve 15 million users daily, so globally, on all the markets that we are active on. So that's a lot of traffic, and that's a lot of data. And thanks to that, our knowledge base, which is our main and the first product that we launched, has now over 250 million answers. Polish people may remember this page called zadane.pl. It was years and years ago. That's how Brainly started, and it grew into this global business now. And what I will be talking about is start with AWS, because many of you already use AWS in your daily work, but some of you may want to start. And usually, when you want to start, all the tutorials start with setting up IAM users and only using access keys to log into the console page, to use terminal. And I consider it very dated, very inefficient, and very insecure, as probably all the security guys will agree. So what I want to show you here is how to use IAM roles and IAM role federation with SAML in your daily work, with your trainings, with your personal projects, on your personal account. And here we will show you how to do it for free using free solutions. Yeah. As I said, you may be already familiar with logging to console and selecting IAM roles, selecting different accounts. It's totally different experience than using direct logging with access credentials. And why this is important to start with, why it is important in your journey as junior developer or DevOps or whatever person in IT, if you want to use AWS. Because eventually, sooner or later, you will face using IAM roles in your daily work. And that's very important to start using it and get familiar with it from the day one. So with that, you can learn how to split your personal AWS account into multiple accounts. I use probably 5 accounts for my personal things at the moment. And it's very easy to set up, as we will show you in a moment. And that's also why it's important for you to start with and learn cross-account access credentials, cross-account role assumption, and so on. What is needed? In this example, as I said, this is just an example. It's simplified operation just to show you the idea, and it's not meant to be a production value. It's just for the purpose of the presentation. So keep that in mind. And for the simplified solution, we just need some operating system. I prefer Unix-like operating systems. For provisioning AWS resources and Okta resources, I've chosen Terraform as a now golden standard for infrastructure as a code. We would need Okta account. Okta is identity provider that can support you in setting up access to multiple services. They support free accounts, and free is good enough for this presentation. It supports multi-factor authentication, although without hardware keys, only with TOTP applications. And of course, at least one AWS account, so we can actually log into something. First of all, to start with, we need to have API token for Okta. This token will be used by Terraform provider to actually create resources in Okta. In this case, it will be some groups in IDP, in identity provider part of Okta, and a SAML application for AWS. And let's see if it will work. Yeah, so here we go to admin panel, get API credentials, and create a new token. For simplicity, we choose all IPs here. Yeah. We can copy the token and save it as environment variable, Okta API token. This envar is used by Terraform provider for Okta, and it will use this token to provision the resources when we run Terraform. Oh, I closed all the, sorry for that. Sorry for that. Next thing, we need to create at least one IAM user. Well, we will create several for the purpose of provisioning the resources. Those others can be deleted. But first, we need to create IAM user for Terraform. As always, there needs to be something that will actually have direct access to AWS, and IAM user is the simplest thing. So we create this user, and this user, after we finish the process, can be deleted. So we log in to the console. We can use root credentials for that. This user will create IAM roles. So we need to have those permissions. And actually, it will also read information about our organization because of how AWS is structured. Because there will be IAM user created for Okta, and for that one user, we will use access keys in Okta to have access to our AWS infrastructure. Yes, and we create access keys for Terraform. and we should store them safely. Stopped. Okay. Okay, now we need to set up providers for Terraform because this is how Terraform will interact with our infrastructure. And here is the default file for AWS CLI configuration and credentials. And here we actually set up the profile with credentials we just created for this AM user. So just what the values were copied, we set up as access and secret key. And using this newly created profile, notice that it's not the default, it's named profile. We can check that account ID will be the same as the account that we've logged in. And now we need to prepare Terraform code. So this is just an example of user mapping that we can set up for the access in our accounts. Here we have example of 2 accounts, and the first key here in this assignment map will be the email of the user. Next element for the value for that object will be ID of the AWS account and list of IAM roles that this user have access to. Yeah, I think it's it for. So this map will be used as assignment map. And in provider configuration, we provide the profile name that we just created in CLI, and we need to also provide organization name for Okta. And now, using all of that, Terraform will be able to interact with our infrastructure. And here it will show us the resources that it may create. We will not go through all of the resources that it will try to create. It will take a lot of time. So now we will actually create the resources. So that will be the SAML application in Okta. It will also, for all the accounts that we've listed in the account mappings there, and all the roles that we've listed there, it will create Okta groups. Because it's the way that Okta assigns access now. We create Okta groups in identity provider part of Okta for all combinations of roles and AWS accounts that we have. And user put into such a group will have AWS application assigned in Okta, so it will show up on his dashboard as an application assigned. Can click on that, and then based on ownership of groups that this user is in, then particular role for each of the accounts will be selectable on the login process for the user. So this is Okta dashboard again. Oh, sorry, that's not the video I wanted to play. Oops. Chyba podlinkowałem złe. Mogę po prostu puścić z dysku. Mhm. Here the only change is that we need to provide additionally Okta API token for the Terraform module that is used for interact with Okta API directly to download metadata XML file. Normally, if you would be creating that, you may create it manually, download the file, then use this file in your repository, for example, or in your secrets, and provide it to Terraform. Here, for simplicity, we will just download this file directly from Okta API, so there's no need to do anything. Just run Terraform. And here we only interact with the master account in the organization. That will create IAM user for Okta, and this user's credentials will be used by Okta to read all the roles in your AWS accounts and all the accounts in your organization. Okay. Yes. So now we will create access keys for that user that just been created by Terraform. So we can go again, no matter where we started. And this Okta user SSO is the user created by Terraform. And as previously, we go to credentials, and create set of access keys. Again, those also can be passed in different way, but they may end up be stored in Terraform state, which is not ideal to store those sensitive data there. So it's just easier to get them there because they shouldn't be changed often because it's just overhead. Okay. Yes, and now we will enter those credentials into Okta provision settings. So now on our applications list, the new item showed up, Amazon Web Services. And because we had those user mappings in this example, users are already there because they are assigned into groups. And we enable API integration with AWS. And those credentials that we just created, we enter here as access key and secret key. In case it doesn't work, if you have multiple accounts and you're adding new accounts and those are not showing here, it may be useful to use connected accounts IDs there and enter all the accounts in your organization that you have. Also, refreshing application settings in applications list may be then possible. Yeah, and this is example of the user logging in. So we are logged in now, and we can work with administrative privileges in AWS console. As simple as that. And now, yeah, what if we have multiple accounts? So in this example, adding new account. Is it again the same? Yeah. Sorry for that. We have technical problems at the beginning. Yeah, so we can add Павеł, if you are watching us, this is the Easter egg for you. Павеł is the former colleague. He also worked in Grand Parade at some point. Yeah, we create another instance of the module. So again, it will create IAM roles that we defined for the sub-accounts, but it will also check if we are using the master account in the organization and not create IAM user for Okta, because only one instance of that user is necessary and it needs to be in the master account of the organization. And here we create credentials profile for AWS CLI, which will be used by Terraform as well. So name of the profile needs to match name of the profile set up in the provider for Terraform. Yeah. And now number of elements to create is lower because we don't create that user. We only create roles in Okta, and we don't create some application in Okta. And now we can check, yeah, those 4 groups are created for our 2 accounts and 2 IAM roles that are created for each of the accounts. And now in the user dashboard, if we click on the login, we will have those 2 accounts and the 2 roles in each account. So we can log into the second account and it works. And now what we are still missing is CLI access, because all of us use CLI for AWS all the time to copy files to S3 or other actions. And I use Gimme AWS Credits. It's a small application wrote by Nike people. It works very nice, and it supports hardware tokens in headless mode, which is not supported by many other solutions. That's why I like this one. Oh, yes, and as stated here, at this point, we no longer need those Terraform users in IAM in all the accounts. They were only for the provisioning of the resources by Terraform. Now, if we change the name of the profiles and we log in here with this or other solution and create profiles for AWS CLI, we can use those profiles in the provider configuration in Terraform to be used by the Terraform, so IAM users can be deleted. We will need to go to Amazon Web Services SAML application settings and just copy this embed link. It will have some random part in it. And this is login. This is used by the login portal by CLI. So it needs to be entered in the configuration. Yeah, in this example, it's the app URL in this configuration file. And in this particular configuration, Give me AWS Creds will create AWS credentials profile for all roles and all the accounts that we have. It can act in a different ways. There are different ways to configure it. And if you use just one profile at a time, you can use the default profile and it will assume only one role that you selected. Or you can have multiple configuration and it can inherit parts of the configuration, and then you can just set different profiles, different IAM roles and different accounts for that, depending on your preferable use case. Because if you have hundreds of accounts and like 20 or 50 IAM roles in each of the account, retrieving all of them will take a lot of time. And in this example, as you saw, we logged in to AWS CLI using now not the IAM user, but IAM role instead. And now replacing the profile name that was previously used by the IAM users, now by the IAM roles, we can run Terraform. And it interacts with the infrastructure. Yeah, so it works. So it connects to all the accounts using the IAM roles. So no more IAM users for the daily tasks. And what next? Yeah, because if you are starting with AWS on your own, now how to do it better? Well, first of all, for scaling, for having multiple accounts, for splitting infrastructure, even for some daily tasks, some of the providers, for example, GitHub provider is very slow. The API has very strict limits that you need to maintain. And if you have a lot of repositories, users, it will slow you down hugely. So for example, you can shift GitHub or some other provider to a different Terraform state, then you will have multiple Terraform states. So how to manage that? And I may suggest you using TerraGrant. It's a very nice tool. I use, I don't know, almost 1,000 now states at work. So it will be not possible to interact with all of them with any other tool. What Okta or other IDPs can also help you with is automating provisioning of users. So based on some attributes that you set for the users during onboarding, you can assign access to certain roles. So for example, you might give access, for example, read-only access to your friend. Using your Okta organization, you may invite your friend and set up attribute read-only, and it will automatically give him access to all your accounts with read-only access. So this friend may help you to, I don't know, find some issues that you encounter, for example. And well, to not run it directly on your terminal, of course, as always, use some CI/CD tools like native code build and code pipeline from AWS. as always, using automation will hugely improve and secure and help you with maintenance, even for your private projects. That will be all.
Thank you. Any questions? All right, perfect.
Thank you for the presentation. So I think I noticed you are only using IAM, and there's like the trust is between each account and Okta. So is there any particular reason you are not using IAM Identity Center to have this relation in one account? And yeah.
Actually, that subject was meant to be presented long ago, like a year ago or something. And back then, Identity Center wasn't, it was called AWS SSO at the time, and it wasn't as improved as it is right now. And still, it isn't as good. Well, now, Okta also works in a different way if you installed it previously, because at my company, we have Okta SAML application installed a couple of years ago, and the access is managed completely different. And we need to update user profile each time. So provisioning is completely different. Now this, they updated actually Okta SAML application to be more in sync with what Identity Center provides. So for example, this approach with having provisioning groups with the account ID and the role name is actually the same as Identity Center uses. So if you are familiar with that, switching to Identity Center is the next step, but that uses SCIM, not SAML.
Okay, thank you.
Do we have other questions? Yeah.
Thank you very much for the presentation. The first question, very simple. Are you going to share your code on this presentation?
Here it is.
Awesome. I'll photo this later. The second question is more wide. I wanted to clarify, does it work with a specific IDP or general with any IDP? Because I consider this solution, for instance, for hybrid cloud solution. So that means if I deploy, for instance, Keycloak, like a local IDP, or if can I use it, for instance, with local Kubernetes and provide access for my service accounts, for Kubernetes service accounts and applications, and provide them access directly to several services within AWS. How does it work? Does it require specific fields? Does it require specific configurations? Or it works only with huge IDP solutions and at all?
No, actually, it works with any IDP that supports SAML. This example is based on the approach used by SAML authentication. So any IDP will work. And for services, yeah, that's why one of the reasons why we should switch to IAM roles quickly in beginning the trainings with AWS is role-based access control. So you, out of the box, have the possibility to use it with RDS, with Kubernetes, with other services.
Probably you haven't got my point. Can I provide specific access for service that I run on standalone Kubernetes cluster and provide, because this service has service account from my Kubernetes, standalone Kubernetes. And in this case, I want to provide access for this service, some resources within AWS. I mean, can I convert token and authentication authorization from standalone Kubernetes to AWS? I mean, provide this chain, I mean, automatically with internal Kubernetes IDP, convert several tokens and provide access, for instance, to buckets, like an example. Just a long chain with hybrid cloud solution.
I think I don't fully understand.
I can pick it up, actually. So the question is about the standalone Kubernetes outside the AWS or inside? Yes. So outside the AWS, you have EM across the different platforms.
Yeah, then any IDP that Kubernetes may support, and Okta is one of them that you can actually.
No. I mean, Kubernetes contains internal IDP. Kubernetes contains internal service accounts.
Kubernetes,
Yes, it's
IDP
my Kubernetes, it's my
by yourself.
etcd, etc., Kubapi, etc. So each service has a service account credentials within my Kubernetes. Can I share this solution? I mean, provide access from my internal Kubernetes with this token, with this EDP. I mean, internal EDP. Connect this Kubernetes to AWS, provide this direct access without sharing keys, because Kubernetes manages all keys automatically.
Yes. Then, because what we create here, it will be difficult to show it now, but what we do here is also create identity provider in AWS. And on master account, or actually on all the accounts, we create identity providers pointing to Okta. So in IAM service. So that's what you will need to do. So you would need to create IDP in IAM pointing to your Kubernetes. And then authenticate users there, and well, in this approach, create the SAML authentication. But you would need to build it on your own, or probably there are maybe some already services that provide that. But yeah, so yeah, that's technically possible, but it would require some work.
Okay, thank you.
Any other questions? Thanks. All right, I have a question. How much time it took you to blur this out from video? I was just like, oh my God.
A lot. I needed to find suitable editing software and learn to track and to blur.
That was amazing, actually.
Do you want some tip? It is possible to unblur things.
I know, but all the credentials created here are scrapped already.
Good, thank you. Any other questions?
Maybe from the internet.
Yeah. Nothing. All right. So thank you very much, Krzysztof. Hey, cheer up a little bit.
And I invite you to the quiz.
We'll give you a moment to fill the quiz, okay? And we will pick up some winners for today. This will conclude somehow this meeting, but
after a short break, yeah?
Yeah, I think we can take a 5 minutes, okay? And after 5 minutes, come back, we will pick up the winners, because you can still scan it, you can still reply your questions. If somebody didn't do it, it's the time, the highest time.
So it's a break. To which hour? You think maybe 20?
Yeah, it's like a 5 minutes. I will announce, okay?
Yeah.
Just a little bit, just to stretch yourself. There is still some pizza, still some beer. So stay a little, and thank you.
Chciałem przedstawiać jeszcze jakiś kąt, żeby nie odróżniać pierwsza i ostatnia cyferka, ale żeby wyróżniać jak klawisz tam było takie pojedyncze. To w Terraformie, bo tego tu zaleciano. Aż tak mi się nie chciało. Miały każda w frame'ach tego ale z AWS-em organizacji po raz kolejny użyłem organizacji, którą stworzył kolega kiedyś na potrzeby tam czegoś. Poczekaj, bo jeszcze coś.
All right, everybody. Sorry. Oh, sorry. Oh, shit. So we have. I think we can announce. Enjoy your stuff. We'll just invite 3 people. The first 3 people will get what is on the table, and the rest of the guys will get vouchers. So we have 8 winners, right? 8 winners. All right. So if we have 8 winners. So now hear me out. The first one is Alek Fidelus. Do we have Alek here? Alek? Co powiedzieć, że jest Alek? No, wygrał pan Alek. We're looking for...
Guys, is there any Alek? Because he's a winner.
No Alek, no problem. Okay, so the next person. So Alek Fidelus. Alek Fidelus. Good. We have you. Right, buddy. So.
Did I win the lottery actually?
Yeah, you win the lottery.
First time.
Yeah, it's not a lottery actually. You reply the question the proper way. So that's for you. Thank you very much.
Thank you.
Yeah, my pleasure. All right. So another one. Read. No, come on. Because people out in the internet waiting as well. So.
Okay, so the next one is Wozik from Germany, probably. Do we have in the room a person with email Wozik? If you are not listening, you won't get a reward.
Yeah, thank you.
Okay, so
Każdego po jednym. Wspaniale i skarpeteczki.
great.
Thank you very much.
Yeah, my pleasure. Our pleasure. Yeah, best show in the town. Thank you. Whew. All right, the third one. The third winner.
Who's next?
So the third winner is Magdalena Bialik. All right, cool. Here is yours, and thank you for good replies. And yes, and we have another winners, and this is the rest of the crew, and they will get vouchers. So on your email, you will get a voucher for AWS service.
Yes, so $50 worth vouchers are going to Dimitri. Are we saying the name? Dimitri Piatrovich. I'm hope pronouncing it right.
You get an email. You'll get it, but come on, get it. Okay.
Let's go.
You can do it. If you are here, you can do it. So you will get an email with a $50 voucher for AWS. So thank you very much for participation.
great.
Yeah, enjoy.
Next one is Goku Balachandran.
Haha, again eating. Haha, getcha. Congrats, buddy. You have $50 voucher for AWS services. You will get an email with that. Perfect.
Great. We are going with the next one.
Oh my God. Drazek Tomasz.
Oh, that was easy.
Yeah, good.
So congratulations.
Thank you.
And Rafał Gadek. $50 voucher. You'll get an email. So thank you very much.
Congrats. Anything more?
Ty Kalanca. Kalanca. Talanca? Talanca? That's how.
Blanca?
Oh, maybe it's an internet. And the last one I left for you. Enjoy.
Norwich, something like that. Great.
Good. On site. Perfect. Thank you very much. Okay, so that's conclude the official part of the event. Now we will move to the backstage discussions at the beer and pizza. So if you're online, you are always welcome to join us. And everybody here, thank you very much. We will meet after the summer vacations the next time. So no, we have another one. Yeah, we have. Yeah, the end of the June. End of the June, we have another one. Sorry, because it was a surprising one, actually. So the end of the June, we'll have another one meeting in Krakow on site, both and the internet. So thank you very much for participation, and see you next time.
And also everyone from the internet.
Thanks. Thank you very much.
Thanks.